are there. Solution of the linear differential equation. This is the most important part, and it covers the 2/3 part of the unit. Okay, then differential equation reducible to LDE with constant coefficient, symmetric, simultaneous, and simultaneous differential equation, and then applications. We understood what the course outcomes are there, what are the POs are there, what is BT level is there. Okay, and then how this unit or how this CO is mapped to the POs that we have written. References we have written. Then we went through the linear differential equation. A differential equation whose degree is at most 1 is known as linear differential equation. Then here our aim is to solve linear differential equation with constant coefficient. Okay, so coefficient should be constant. Okay, this much part we studied yesterday. Now we are going through the next part. Now we'll start with the general nth order linear differential equation with constant coefficient, and then we'll understand how we can solve it, and then we'll start with the complementary function. So our aim is to complete maximum part of complementary function in today's lecture. Okay, so let me continue. So hope everyone is writing it on the notes. Use a notebook. Okay, 1 minute only. Yes, here we are. So page number 4, right? Write the date. Okay. So the general nth order linear differential equation with constant coefficient is a naught d raised to n, nth order na, therefore dx raised to n minus 1 plus a1 d raised to n minus 1 y divided by dx raised to n minus 1 plus a2 d raised to n minus 1 y divided by dx raised to n minus 2. Okay, and so on until a and y equal to some function of x, f of x. This is general nth order linear differential equation with constant coefficient. Okay, now I'm using a notation, right, where first you mention this, where a naught, a1 up to a, what they are? Constant coefficients, na? Constants. Okay, notation. Understand the notation? We are considering d by dx equal to, it is not equal to, it is equivalent to. Therefore, 3 lines are there, capital D. So d square divided by dx square, what it will be? That will be equal to d square. And tell me what will be d raised to n divided by dx raised to n? That will be equivalent to d raised to n. So let me use this notation in above equation. I'll say this as equation number 1. So let me use them in equation number 1. So a naught as it is. Okay. Then see, this d raised to n divided by should be x raised to n. Dx raised to n. That will be equal to d raised to n. And then y is there. Plus a1. Then d raised to n minus 1 divided by dx raised to n minus 1. This part is d raised to n minus 1. Y. Plus a2. What are the next term will be d raised to n minus 2 y. And so on. Up to a and y equal to f of x. Okay. Now, from the left side, I can take y common. So let me take y common. D raised to n plus a1 d raised to n minus 1 plus a2 d raised to n minus 2 and so on up to an y equal to f of x. So you might have observed that this whole bracket, this is the function of d. Right? The different powers of d we are taking. D square, d cube up to d raised to n. So I'm writing it as phi of d, some function of d, phi of dy equal to f of x. So this is nth order linear differential equation. Okay, whether I say equation number 1 or equation number 2, both are same only. Writing equation number 1 every time is cumbersome. Okay, so now onward, whenever I am saying nth order linear differential equation, write the equation number 2 and we'll understand it. Getting everyone? Equation number 1 and 2, both of them are same only. Okay. Okay, let me go ahead. Okay. Different solutions we want to understand, huh? Okay. Solution of a differential equation. A relation, definition, a relation between x and y, or you can write the dependent and independent variable, that satisfy the given differential equation is known as. Okay. Now write three types of solutions. Three types of solutions. Right. One, general solution. A solution where number of arbitrary constant is equal to order of differential equation is known as general solution. Right? Number of arbitrary constant equal to order of the differential. Then add particular solution. When arbitrary constants are replaced by particular or specific particular values in general solution. It is known as third. Third is not part of our syllabus. Just we'll try to understand it. Right. Singular solution. A solution which cannot be obtained by any method, but it is solution, is known as singular solution. We'll try to understand what is general solution. So once we start the example, I will let you know what is general solution is. Okay, now return. On the next page, can I change the page?
Sir, 1 minute.
Yes. Those who are using mobile, this is visible, na?
Yes, sir.
Yes, sir.
And those who are using the laptop or PC. I think for them also this is visible.
Yes, sir.
Any changes required in this writing method?
No, sir.
Anything that you want it on the board? It's not like that, na? This is okay, na?
Yes, sir.
Yes, sir.
Okay. But I don't know what about other lectures, how they are taking. If any other method is there, which is better than this and possible for me, both the things are there. You let me know. But let me know it at earliest. Okay, let me change the page. Next is page number 5. So, right on. Consider, we are starting with our topic, huh? Right on. Consider general nth order linear differential equation with constant coefficient as, yes, what is that? Written like this, phi of dy equal to f of x. Okay, now written. Its general solution is y equal to, our aim is to find y equal to y of c is the suffix, plus y of p. Okay, what is y of c? Known as CF, complementary function. What is y of p? Known as particular integral or particular solution. Now we'll try to understand what this complementary function is and what is this particular integral is. So we'll start with the next part, complementary function. Right. The solution of nth order linear differential equation with constant coefficient obtained by considering right hand side of the differential equation. Right hand side of equation number 1, right hand side equal to 0 is known as complementary function. That is solution obtained from. So in equation number 1, substitute right hand side equal to 0. So solution obtained from this part only. Now question remains what to do about the right hand side. That we'll study in the particular integral. Okay, so now onward, what we are doing, if right hand, for many of the examples, there is already the right hand side equal to 0. So then you don't have to do any change. But if right hand side is not 0, we have to consider it as a 0 and then we have to solve it. Samajhte sarvana hai? Getting everyone? Okay?
Yes, sir.
Yes.
Yes. So write down, below this write down the auxiliary equation. Auxiliary equation. Okay. Phi of d equal to 0 is known as auxiliary equation. If we leave the y and phi of d is remaining, so that is known as auxiliary equation. Okay. Now write down next. 1 minute. I will not derive the formulas. I'll go to the next part directly since we don't have that much time, right? The complementary function depends on nature of roots of auxiliary equation. Right? Complementary function depends upon what? Nature of roots of the auxiliary equation. Okay. What is meaning of this? For example, we'll go through one example so that afterwards there will be no any confusion. Huh? So say we have this differential equation dq d square y divided by dx square, right? Then minus 5 dy by dx plus 6y equal to e raised to x into sin x. Right. So we can write this as d square minus 5d plus 6y equal to e raised to x sin x. Getting everyone? Using the notation? Right. So to find a complementary function, what we have to do? Right hand side equal to 0. That is, we have to solve this. D square, sorry, minus 5d plus 6y equal to 0. Now tell me what is auxiliary equation here. What is auxiliary equation here? So auxiliary equation, that is d square minus 5d plus 6 equal to 0. Okay. Now what are the factors? D minus 2, d minus 3. These are the factors. Okay. And therefore, just 1 minute. Yes, madam. Right, madam. Let me check that. Right now I'm in office. Let me check that. Okay. 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 Sorry, there was little bit disturbance. Yes. So see, the roots are d equal to 2 and 3. So roots are real numbers and distinct. So depending upon the nature of roots, whether roots are real number or complex number, this is one criteria. And second, whether roots are distinct or same. 4 formulas are there of the complementary function. Huh? So let me write the 4 formulas. But before that, do you want to understand derivation of one of the formula, or should I write the formulas directly? What should be done?
सर एक बेसिक आइडिया चाहिए ना कि फॉर्मूला कैसे आया.
हाँ चाहिए सब, लेकिन क्या है, it takes more time and usually we have 7-8 lectures to complete the unit. That is the problem, but no problem.
Directly go with formula.
No. I'll tell you how we got the first formula. See, again, to understand all these things, basics of the mathematics, they should be known to you. And unfortunately, those from the DSE, they have not studied the M1 and M2. Huh? But no problem. We'll try to understand. Huh? So see, what I'll do now, I have changed the page now. What I'll do now, I'll solve the same differential equation by 2 different methods. Right, and we'll try to understand what the how the formula is developed and what the concept that we are using in the M3. Okay, so formula is It is not compulsory to write this part. You can leave this part. Okay. So I'm using the M1 method to solve differential equation dy by dx minus my equal to 0. Our aim is to solve this differential equation. M is constant. Okay. So for this, what I will do now? Whatever we studied in M2, not M1, M2, that I will use. M2 method. And I think it's not difficult also. But the diploma student, they might have also studied this somewhere. So dy by dx equal to my. Right? We have to solve the differential equation. So we have to separate the variables. So it is like this: dy divided by y and m dx. So what I have done now, I have written all the terms in y on one side, all the terms in x on other side. M is constant. You can write m on left side or right side, doesn't matter. Okay. Now to solve the differential equation, we have to integrate. And hope everyone know that whenever we integrate, we have to add a constant. Okay. So what is integration of 1 upon y? Log y. What is integration of dx? X plus constant. But our aim is to find y. So take antilog e raised to mx plus c. And we know that it can be written as e raised to mx into e raised to c. Right? E raised to a plus b formula that I have used. E is constant, c is constant. So I can replace this by a single constant. This is the solution that we obtained from the M2 method. Okay. Now let me use the M3 method. Till we have not studied it, but whatever we studied till that I will use M3. So we have differential equation like this. Differential equation is d minus my equal to 0. Now tell me what is general solution. General solution is y equal to y of c plus y of p. Yes, but what is y of p here? Y of p equal to 0. Why? Since right hand side equal to 0, therefore no right hand side. Okay, so y equal to y of c, and this is the y, which implies, so comparing with 1, this is the one, y of c equal to c1 e raised to mx. And how to understand this? See, complementary function is obtained in this way. To find the complementary function, we'll consider d minus my equal to 0. Then we'll consider the auxiliary equation. What is the auxiliary equation? D minus m equal to 0. From here, we'll find the root. How many roots are there? One root. So one constant will be there. And therefore, y of c equal to c1 e raised to, this m is to be written in power e raised to mx. Getting everyone? This is the formula. Suppose two roots are there. Okay. Can I write it here? Can I write it here? Say one differential equation is there having two roots, d equal to 2 and 3. Before some time we studied this example, d equal to 2 and d equal to 3. Then what will be the complementary function? Complementary function will be, see, corresponding to 2 we have e raised to 2x. Corresponding to 3 we have e raised to 3x. Okay, and then since two roots are there, order of differential equation is 2, and therefore two arbitrary constants will be there, and then it will be like this: c1 plus c2. Getting everyone? C1 e raised to 2x plus c2 e raised to 3x. And how it is obtained? Obtained by this method. This method is used. Okay. Say something.
Yes, sir.
Understood.
Yes, sir.
Understood. Okay. So can we proceed now? Let me write the formulas. Okay. What was the previous page number? Page number क्या लग सकते हैं?
5.
5. So this was 6. This will be 7. Sorry. Next, write formulas. Right, real roots. Real and unrepeated roots. Suppose roots are m1, m2, m3. How many roots are there? 3 roots are there. So what will be order of the differential equation? 3. So how many arbitrary constants will be there? 3. Like this, huh? You understand this. So y of c equal to c1 e raised to m1x plus c2 e raised to m2x plus c3 e raised to m3x. Understood? Okay. Second part. Real and repeated roots. So say m is there. Next root is also m. Next root is also m. So how many roots are there? 3 roots are there. And then what is the what is the complementary function? Like this, c1 plus c2x and then e raised to mx. Okay, next. Complex roots. Complex or imaginary, huh? Complex and unrepeated roots. Say d equal to alpha plus I beta. Alpha minus I beta. So 2 roots are there. One is alpha plus I beta and other is alpha minus I beta. Okay. So right here, real part. What is real part? Alpha. What is imaginary part? It is not I beta, huh? It is beta only. Whether you consider plus beta or minus beta doesn't matter, huh? Therefore, I have considered it as a beta only. And in this case, the complementary function is c1 cos of beta x e raised to alpha x. Next. Complex and repeated roots. So say d equal to alpha plus I beta, 1 root. Alpha minus I beta is second root. But we want repeated roots. Okay, so alpha plus I beta is repeated. But once alpha plus I beta is 1 root, now by default alpha minus I beta will be the second root. In fact, complex roots appear in pairs. So if alpha plus I beta is 1 root, now by default alpha minus I beta will be the second root. So how many roots are there? 4 roots are there. And therefore, complementary function is like this. Y of c equal to c1 plus c2x into cos of beta x plus c3 plus c4x sine of beta x into e raised to alpha x. Okay. Then below this write down note complex roots appear in pairs. Means if alpha plus I beta is one root, by default alpha minus I beta is the second root. These 4 formulas we have to remember. Any doubt about these 4 formulas? Yes.
No, sir.
Those who want to understand how these formulas are obtained, you can refer the notes that I have posted on the Google Classroom. Right. Last time when I taught it same subject for the civil engineering student, at that time we had much time. We got around 5 to 6 months to teach them 3, and around I took 90 lectures. Right. For you, I have only 50 lectures. In fact, less than that. So probably it will be difficult for me to derive the formulas. Okay, so already they are derived, they are there in notes as well as they are in the video lectures also, if you want to go through it. And I have given you references, so you can use the references also to understand how the formulas are obtained. Clear now? Can I go through the examples now? Can we start with the examples?
Yes.
Yes, sir.
Okay, so write on next page. Page number 8. So this is very important part. You have to remember the formulas. Huh? Tomorrow I'll ask you the formulas. In next lecture I'll ask you the formulas. So by next lecture you remember the formulas. I do understand derivation is very important, but in engineering, see, in exam the derivation is not asked. Therefore, students are usually not interested in understanding how the formulas are derived. They are interested in knowing how the solution is obtained. Okay. So they can use the formula directly. So right now, examples. At examples, find CF for following differential equations. I will not repeat question again and again. Same question will be there for all the differential equations. Or the question may be solve the differential equation. Okay, meaning it's same. So right now, first d square y divided by dx square minus of 7 dy by dx plus 10y equal to 0. Solution. Right. Now start writing with me. If somewhere I am getting fast, you let me know. Instead of telling me it at the end, after completing the lecture or completing the syllabus, if I am going fast anywhere, you let me know. Okay, so write with me. The differential equation is d square minus 7d plus 10y equal to 0. Isn't it? Now write down auxiliary equation. Yes, find the factors. Hope everyone know how to find the factors. unrepeated. So can anyone tell me what is the formula?
First formula.
C1 e raised to m1x plus C2 e raised to m2x. Only two roots. So no need to write C3 e raised to m3x. Right? Therefore, what the complementary function is? C1 e raised to 2x. That's it. Understood this?
Yes, sir.
Okay, right. Note. Order of roots is not important. What is the meaning of this? That is, above solution may be written as y of c equal to c1 e raised to 5x plus c2 e raised to 2x. Same as ahead. Whether I write c1 with e raised to 2x or e raised to 5x, it is arbitrary constant only, na? So same only. Getting everyone?
Yes, sir.
But usually what we do na, for uniformity, we write the roots in ascending order. The lowest number first and then in increasing order we used to write the roots. Getting everyone? Okay? So that there should not be any confusion. Yeah, how to write the roots. If you write answer in the form of whatever is written in red color or pink color, both are same. Okay. Can we proceed now? Can we go to the next example? जरा बोलत जा.
Yes, sir.
हा म्हणजे मला समजते की तुम्हाला समजलेलं आहे किंवा झालेलं आहे तुमचं. सेकंड एक्झाम्पल राईट डाऊन. D square y solve this. Try to solve it yourself. Getting?
Yes, sir.
Isn't it?
Yes, sir.
Very good. So next, can I change the page?
Sir, 1 minute. Sir, done.
Okay, so next example. Repeat it. Yes, use this formula. We can write solution in this way also, huh? Both of them are same only. C1 plus C2x or C1x plus C2, one and same only. Getting everyone? Jette, Sarvana.
Yes, sir.
Yes, sir.
Next. Fourth example. See, it is not possible to find real roots. Okay, hope you know the formula. Using what are the roots of quadratic equation? आठवते ना minus b plus minus b square minus 4ac divided by 2a असलं काय आठवते ना?
Yes, sir.
Right, equation is like this: ax square plus bx plus c equal to 0. Then these are the roots. Hope you remember all these things very well. Okay, if not एक बार revise करा. So a is coefficient of d square, b is the coefficient of d, c is the constant. Okay, so let me use them. So d equal to minus b plus minus b square 2 square minus 4 into a into c, 8 divided by 2a, a is 1. Hope anyone remember that root of negative number does not exist. So see, you might have observed, केलं का इथं plus minus आहे पहा. So if minus 1 plus I is one root, by default what will be the next root? Minus 1 minus I, and therefore complex root appears in pairs. Getting everyone? Now real part. Alpha, what is real part here? Minus 1. Imaginary part, that is beta, and what is that? I and minus I. But you don't have to write I, huh? You have to write its coefficient, that is 1. Getting everyone?
Yes, sir.
Yes,
Okay. Now, formula number 3. What is y of c? C1 cos of beta x plus C2 sin of beta x to e raised to alpha x. Okay, so just add, substitute the values only. So y of c equal to, final answer is like this. C1 cos of beta is 1. So C1 cos of x plus C2 sin of x into e raised to alpha. Alpha is minus 1. So e raised to minus x. This is the complementary function. Are you able to find these answers? Jete?
Yes, sir.
Okay, so we have a tutorial today, huh? So during tutorial, I will go through the formulas. A3 batch बरोबर चला A3 batch आहे. Formulas of the derivative integration. मी तुम्हाला ते ह्याच्यावर पाठवतो, ग्रुपवर पाठवेन ते. तर ते आपल्याला एकदा सर्व लिहायचे आहेत. We want to write them and by heart them during the tutorial only. DSC students understood? काय म्हणते समजलं?
Yes, sir.
Okay, great. चलो. Time being, will stop here. You join the next lecture. Already I have taken the attendance. Bye bye. Bye bye.
Thank you,
सर
हाँ बोलो.
सर इमेजिनरी पार्ट में हर बार कोएफिशिएंट ही लिखना पड़ता है क्या आई की जगह पे उसका?
हाँ, correct.